From an N-finite perspective, the continuum hypothesis has a definite answer that we will actually be able to determine if we argue within this framework for long enough. So briefly, in terms of just explaining what N-finitism is, it's a really simple notion that the good properties of finite objects, basically their universal computational background definability, should be extensible to other infinite objects. So it basically just says, for an object of size n to exist, to be mathematically admissible means that there is a program of size n that can construct it in n number of steps. In the finite case, this gives exactly the same results as finitism. In the ALF1 case, it gives the most conservative discussion of finitist values that can be extended. So it gives the result that for an object ALF1 to exist, it can be constructible in ALF1 number of steps. Now, one of the interesting things about this is mathematicians have lost faith that there can be universal answers to what size of mathematical objects exist, and it's because their only criterion is the consistency of the given system. In most cases, unless they're constructivist, in which case they likely have way too heavy, way too restrictive of set finitist leanings that aren't open to discussion. From an N-finitist perspective, this discussion is very simple. It's, can we define good notions of hypercomputation, and can we define even a single hypercomputational process that has a definite definition that could actually construct an object between the natural and real numbers in size. So, yeah, without any form of Platonism, it brings back the hope of a universal answer to this question rather than just getting stuck in the mathematical multiverse perspective. It's very interesting, and it's sad that it hasn't been looked at all.